Okay, so who am I? My name's Jack Sheldon. I've been at the IEC for 30 years, and you can see 30 years in the IEC gives you lots of grey hair. And it's fairly typical for people who work in standards. They tend to stay there for a very long time. And you'll see towards the end of my presentation that people get quite passionate about standards. It's quite interesting to see that. Basically, got 5 chapters that I'm going to talk about, where the IEC started off from, and I think this is actually quite important. You're going to see some of the concepts that Daniele reminded you of at the beginning. You're going to see them here in action. So where did the IEC start off from? Why did it start off? And where are we today? So we're going to then move forward 100 years to where the IEC is today, what it does, and so on, and how it works. And then I'm going to take a standard. You're actually going to have a look what the inside of a standard is. Don't worry, I'm not going to get too technical because I'm not expecting you to understand the techniques of a standard, but you'll be able to see the structure of a rather important standard in the IEC, protection against electric shock, sort of things that you don't want to have really as electric shocks. How you get involved in standards work, because I think it's important. Standards don't happen. There's an important process. We talked about this business of openness, participation, consensus. These aren't just words, these are actually things that happen, really. And at the end, I'm going to talk a little bit about conformity assessment, because it's all very well having a standard, but you need to be aware of how it's applied and how people are making use of it. A standard on its own won't actually do anything. You need to be able to check that people are using it properly. And conformity assessment is doing that. You assess the conformity of a product or a service against a standard. So let's start off by talking about the origins of the IEC. The IEC was founded rather over 100 years ago to look at cooperation on issues of electrotechnology. And I'm going to sort of come back to my colleagues in ISO. The IEC is a bit older than ISO was. The IEC was set up 100 years ago, and it deals with electrotechnology. So anything that's electrical, has got electrons around it, and you've got some examples down there below. And you can see it covers everything from mobile phones to nuclear power stations. We tend to have standards that cover most of those kinds of things. Colleagues in ISO came up a little later on, and they effectively standardized just about everything else. So there's a historical reason for having the two organizations. So what is the IEC? Well, it's a global organization. The WTO, the World Trade Organization, recognizes the existence of organizations such as ISO and IEC. You're going to see the word consensus-based probably a lot during this course, and I think consensus is, if you retain nothing about what you've done, what you're going to be doing here, I think the word consensus is probably the word that's the most important one. So that the idea that we develop consensus-based standards is a theme that's going to be recurring all the time you're going to be listening to talks about standards. I'd like to be able to explain what consensus is. And if I could summarize it in one word, I'd say coffee breaks. Okay? Because most of the consensus actually occurs during coffee breaks, amazingly enough. And you can have people sitting around a room, and a lot of standards meetings are a bit like this. You've got people sitting around a room, roughly that kind of number, maybe 20. Sometimes you have meetings with hundreds of people in, but 20 to 40 people would be fairly normal. And they'll sit around debating. But really, when the consensus occurs, it's in the coffee break, when the meetings break up and people get together and start networking. So that's the way I would define, and you know, that's a credible thing to say. I'm not joking about it. It's very serious. The networking aspects of developing consensus is actually a fairly critical part of the way the organization works. Conformity assessment, as I say, that's evaluating how a product or service meets a standard. And the IEC has got 3 conformity assessment systems in place. and I'll very briefly introduce those right at the end of my presentation. And it covers, the IEC covers all electrical and electronic products, systems and services, and we call that electrotechnology. So it's the term we use. Again, that's another aspect you're going to find important, terms and definitions. We need to understand mutually what we're talking about. We're an international organization. A lot of the people don't necessarily even speak English or don't speak it very well. So terms and definitions are a critical aspect of what we do. So electrotechnology, electrical and electronic systems, products and services. So that's the definition we use. So let's go back 110 years or so to when a bunch of people got together at the World Fair in St. Louis. So this happened at the World Fair in St. Louis. And a bunch of people, Chamber of Delegates, it's marked on this original document. This is an original document. As you can see, the typescript is a bit funny. Got together to consider the question of the standardization of the nomenclature and ratings of electrical apparatus and machinery. So again, we've got this notion of nomenclature and ratings. Okay, ratings we'll talk about a bit later. But terminology, what do we mean when we're talking about electrical apparatus and machinery? Historically, and this doesn't actually appear here, but you find it in some of the historical documents, this started off because the English were trying to sell, the British were trying to sell electrical goods, trying to export electrical goods into the United States and wanted to impose their standards on those of the United States. The United States at the time was much smaller than it is today in terms of its economy. Okay? And the British still had a big empire and all the rest of it still. Okay? So think of it the other way around from where it is today. And the British were trying effectively to impose what they were doing it, but they were doing it through this Machiavellic system of creating a standards organization. Okay? But the principle actually still holds valid today, to standardize nomenclature and ratings. They actually moved very quickly because 2 years later, they actually set up the organization. So the organization came into existence 2 years later. And right at the beginning, there's something which was said by Lord Balfour, who opened the organization's first meeting. And he said something which is actually perfectly valid today. If you look at those lines that are highlighted in the middle, to describe the qualities of different machines that whilst the man, I'm sorry, it was sexist in those days, whilst the man who buys and the man who sells will know exactly what each respectively is doing, there will be the freest initiative left to both, to the man who designs the machinery. In other words, it's a way of reaching agreement between a buyer and a seller on what you're buying and selling. Okay? And that's actually perfectly true today. There's nothing that's said in there, apart from the rather sexist way of looking at it, that's not true today. If you take that part of it out, still perfectly valid. So that was said 110 years ago. Another key thing that came out in their rules, to have the advice of manufacturing interests. It started off as a sort of quasi-governmental thing, but there was this push to have industry present as well. Okay? And that still persists today. I think this is vital. The standards are developed by the people who are making the things that they're standardizing. That is very, very important. Okay? So it's an agreement amongst the people. I'm going to come back to consensus. You get the consensus of people agreeing amongst themselves on doing things. I think that's one of the big strengths of the standards process, is that people agree on it. It's not government dictating to you what's going on. In that sense, it's a very different thing. It's a voluntary system, which has worked very, very, very well, in fact. Okay. Well, when the IEC started off, its first president was someone very illustrious, Lord Kelvin, the guy whose name is used in measuring temperature today. very illustrious. And we had a secretary, a Colonel Crompton, obviously military, and the acting secretary was a Mr. Lemaitre. So by the time we got 10 years on, and this was the beginning of the outbreak of the First World War, these were the standards that had been published by then and agreed at that time. Terms and definitions for electrical machinery. And the electrical machinery was the thing that drove the whole organization right at the beginning. But then there were a whole pile of other things that came on later on. Letter symbols for quantities and units. And again, we're talking about terminology. Amps, volts, kilovolts, all terms that mean something to you, even if you don't understand what they are. Volts are what make you go ouch when you put your finger into a plug, something like that, okay? So these are all important things that need to be agreed between the parties. What is a volt? How do you measure it? Okay. Resistance of copper. Well, copper is still used widely today. It's what you make wire and cables from. Okay, you start making it with glass today as well, but there's still an awful lot of copper, and the only way you can transmit electricity is through copper today. Aluminium as well. The oldest standard in the IEC's catalogue deals with the resistivity of copper. It dates from 1930. So we had the first edition in 1914, and it got revised a few times, and we haven't revised it since about 1930. I don't remember the exact date. And that actually makes sense because the resistivity of copper doesn't change. It's a constant. And again, definitions, terms and definitions. Hydraulic turbines. Hydraulic turbines are turbines, machines driven by water to generate electricity. So hydro power uses hydraulic turbines. A lot of the hydropower you find here in Switzerland, for example, there are installations that are 60, 70, 80 years old, and they're still working perfectly well. So we've got standards that go back, really back to that time already still. And then other electrical rotating machines and turbines. So that was what the IEC started off. It was heavy. This is big stuff. These are not little things that you can take in your pockets. Big, heavy machinery. You had 4 technical committees. One on nomenclature, in other words, terms and definitions. One on symbols. How do you represent those terms and definitions? Rating of electrical machinery. So my electric motor is 30 watts, 30 kilowatts. What does that mean? How do you measure it? And prime movers. These were electrical transportation systems at the time. That seems to have disappeared off our radar in more modern times. Let's move forward 100 years and look at what the IEC is like today. So the IEC, at the end of last year, 170 technical committees. And I'm sorry, this slide's got lots of jargon on it. I'll try and explain it to you. So 170 technical committees. Each of the technical committees looks after a particular domain within the IEC. You saw we have standards on nuclear power stations, on mobile phones. Each of the committees deals with a specific area. Within those committees, you have what we call working groups, project teams, and maintenance teams. That's what the WGs, PTs, and MTs are. So you break up the work into smaller groups. And there's about 1,200 of those. And the total number of experts who actually write the standards, because it's not us, it's not me who writes the standards. I can't write a standard. I may be an electrical engineer, but I don't know everything that the IEC does. We have real experts, and you'll hear what a real expert is right at the end. The number of experts who actually write the standards, about 13,000 of them, spread out all over the world today. They literally are spread out all over the world. And I put approximately, because actually we don't really know terribly accurately how many we've got, because they don't work for us at all, okay? They work in small committees, and these working groups, they're nominated by their countries to participate in those groups. At any time, we've got about 1,500 active projects. These are projects that people are working on, standards that are being written at any one time. The catalogue, the number of publications that you can buy today is just under 7,000. It's probably a bit over that now. And in any year, we publish just a bit under 500 standards. Now, some of those are revisions of existing standards. But obviously, a lot of them are new standards dealing with new technology or whatever. It takes us a bit under 3 years, on average, to develop a standard. Okay? I'll come back to consensus. Consensus doesn't happen just like that. It takes time. The reason it takes 3 years is because these are consensus standards and not dictated by anyone. And you'll talk to anyone who does real standards, and they're going to come up with a number that's somewhere around that ballpark. Okay? Anyone who tells you they can develop a standard in a year is not developing consensus standards, in my opinion. You're then dealing with consortia standards, de facto standards, or things of that kind of nature, where you don't need to develop a full consensus like you have there. So, what sorts of things do we have standards for? Well, electrical safety is an obvious one. And that's probably what most people would recognize, electrical standards that are covering safety. Home appliances, we've got a whole bunch of things covering home appliances. All the laptops that you guys have got on your thing, there are a whole bunch of safety standards dealing with laptops. Medical equipment. Medical equipment which has got electricity in it, like the scanner that you can see on the picture there. There are, again, lots of standards dealing with the electrical safety of electromedical equipment. Consumer electronics. You've got an illustrious person coming next week, if I remember correctly. Next Wednesday. Mr. MPEG is the way I describe him. A very good friend of mine, actually. All you guys have got iPhones and all the rest of it, all the videos, the sound on there, it's due to standards. It works because of standards. Leonardo, who's coming next week, will explain to you the importance of those standards. And those standards work together to allow you to do these kinds of things. It doesn't happen automatically. A good standard is one which works in the background that you don't see. Interconnectivity. Oh yes, well that is actually the big bane of standards organization, trying to get bits to work together. See, most of you have got Macs here on the tables there. Try and get a Mac to talk to anything else, okay? It's fine when you're in the Mac world, when you're in an Apple world, perfect. Try and get any Apple product to talk to something else. And that's a choice that Apple have taken. They've taken a choice that they want their universe to be their own, okay? And you're going to find yourself very difficult to buy yourself out of the strategy again, huh? Because it's going to be very expensive once you're locked in. Okay? I mean, there are other products that are in the same way. There are razor blades. Okay, that's one. Printer cartridges is another one as well. Okay, you know, there are whole piles of products like this as well. But again, I don't want to get too much involved in this. But interconnectivity is actually a big issue because there is a will in some industries to get products to work together. Okay, I mean, I've given you a whole bunch of products that don't work together, but there are actually products that do work together, and there is a will by industry, sometimes pushed by consumers, to get the products to work together. Some of the things we are looking at and that are really important for us are things, and I've used the word smart electrification there. There's a study that was published by the IEA, the International Energy Agency, a few years ago, which saw an increasing use of electricity to manage the energy crisis. Electricity has got one huge advantage over other sources of energy, is that you can switch it on and off. It's much more manageable than most other sources of energy. So there's going to be a huge increase in the use of electricity, and that means transformation of other sources of energy into electricity because you can manage it much more easily. It's very difficult to switch off oil fires and things like this. And they can't be managed very easily. There's going to be use of electricity to manage other electricity sources as well. You're seeing much more of this in smart homes. Renewable energies, obviously people are going to be using that. I always maintain that one of the oldest forms of renewable energy is hydropower. Been around for years and years and years. And it contributes something like 60% of energy, of electrical energy here in Switzerland, for example. And the Swiss are very lucky to have that as a resource. Sorry? Norway's another one as well, of course, yeah. And then electric vehicles. Okay, electric vehicles, they sort of come in waves and go again, they come and go again. But there's certainly a future for them, okay? I think once, my own feeling is that some day or other there's going to be a sort of quantum breakthrough in battery technology, because that's what's holding up electric vehicles today. And once that quantum breakthrough in battery technology comes, then electric vehicles will really take off. And I don't know when it's going to happen. It may never happen, which would be unfortunate. But unless that happens, I think electric vehicles are going to be a bit tied down, and that's a bit of a shame, really. Because they're, in fact, significantly more efficient than petrol vehicles. Much more efficient. There we're really talking about huge savings in energy all round. Okay, so those are the sorts of things we're looking at. Electric vehicles, yeah, one of the biggest things is how do you recharge them and where do you recharge them? So there's a whole pile of infrastructure that needs to be put in place to service electric vehicles, in fact. It's not just a matter of plugging them into a plug here. It's actually much more complicated than that. So how does the IEC work as an organization? Well, the IEC develops international standards. And we have this difference between international standard and national standards. International standards that we develop are actually voluntary. No one is obliged to use them. So what we do is to encourage our members to make use of those standards, and the best way they can do that is by adopting them. That means there's a process in place within their country to adopt the international standard as a national standard. Sometimes they do that simply by saying, we're going to use the international standard. That's the simplest way of doing it. Stimulate world trade. Standards are important. The main reason we have them is for trade. Okay? You don't need international standards if you're not going to trade. There's no point in that. You can just stay at home and write your own little local standards. But we live in a globalized economy. And again, I'm not going to get into discussions whether globalized economies are good or bad or indifferent. Do that in some other course. Okay? And it'll take 10 lectures, and I've only got 10 lectures. But we do live in a globalized economy. Goods are traded. And that's what standards are for. I'm not talking about it today, but we take the example of the plug and socket, which is a real problem because every country has their own plugs and sockets. It's because when countries put together their infrastructure, yeah. I'm just going to give you the historical reason of why we are where we are today on this. When countries put together their electrical infrastructure, which was probably in the 1950s, 60s, that's when we had this huge expansion of electrical installations, people having electrical appliances and all the rest of it. Goods were not traded internationally. You bought have we got anyone from Italy here? No one from Italy? Yeah, you're from Italy. Yeah, you buy a fridge in Italy, it was made in Italy. Okay. You buy a fridge in the UK, it was made in the UK. There was no exchange of goods, or very little exchange of goods, across borders at the time. So every country put in their own electrical infrastructure. And we ended up with the mess we have today, that whenever you travel, you have to put up your adapters. Because changing what's there today would cost a fortune. Okay? We'll look at infrastructure a bit later on, because it is one of the barriers to international standards. Okay, make the results available and applicable. So the idea is that we have standards that can be used internationally wherever possible. And we also set the framework for conformity assessment to the standards we have available. So what does the IEC look like? Okay, so this is what the organization chart of the IEC looks like. That's the administration. The IEC Council is the members of the IEC. The members of the IEC are countries. There's one member in each country. And then you have a sort of board of, you have a board of directors and so on. Okay? I don't want to get too heavily involved in that. What is interesting from our perspective is this bit around here, because this is what I call the powerhouse of the organization. This is what develops standards. Okay, so standards managed by a board, and I'm responsible for this board here. And then we have all these 13,000 experts working on all our committees here. Next to that, we have a market strategy board, which is a sort of think tank. Looks at developing new perspectives for the organization. We only set it up about 5 years ago, so it's a relatively new animal within the IEC. But it has come up with lots of useful things. It's come up with our policy to deal with renewable energies and so on. And then finally, all the work we do on conformity assessment and the way it deals with conformity assessment. So that's the way the organization works. And remember, most of the people don't work for the IEC. So the IEC is a voluntary association of national committees. So the national committees are the people who are the members of the IEC. They have an obligation to represent all the interests in their particular country. So we talk about interests, stakeholders. These are terms you'll find coming along a lot. And I've listed some of them. They're the most important stakeholders you come across. It's not necessarily a complete list. But government is an important stakeholder, industry, testing laboratories, academia, and even consumers. After all, they're the ones using the products, after all. Consumers are another problem. I don't want to get too heavily involved in them, but they are an important aspect of what we do. Membership, one member per country. Like the UN, it's not individuals who vote, it's the members who vote, and those are the countries. And we have two classes of members, full members and associate members. We'll have a look at that in a minute. And we have a program for developing countries, which we call the affiliate country program. So what do the national committees do? Because the national committees are an important element in the IEC. They are our members. They support, obviously, the conformity assessment schemes. And that actually answers your questions. They coordinate each nation's consensus viewpoint. Okay, so they're the ones, you need a national committee to reach a single viewpoint within that country. It's one of the problems when you have a country type of organization. You might have the government saying black and industry saying white. And somehow they're going to have to reach agreement and say grey when they come to a meeting. That's an option. So the national committees have to come to a single viewpoint within their country. The full members obviously can get involved in everything we do. And as I say, it's a one country, one vote system. So Albania has the same voting power as the United States. So these are the different types of participation in the organization, the full members, the associate members, and the affiliates. We've got 60 full members, 22 associates, and 82 affiliates. And the full members, full members can actually do everything, take part in everything. The associates, rather more restricted, and the affiliates can only be informed on what's going on. They can't actually take part in any of the work. So it's an information process. They actually don't pay anything either, so that's okay. And that's basically our list of members and associates. Okay, so you can see we cover pretty well all most of the world in one way or another. Okay, the ones in green are actually associate members. Just a couple of graphs to illustrate the importance of electricity, and you can see it's growing. Not surprisingly, it's in the affiliates, in other words, in the developing countries, that there's the biggest growth of electrical consumption. Okay, because they started off from much lower down. So the growth in developing countries in the use of electricity is much greater than in the developed world. And that will continue, of course. We talked about the offices that run the organization. The main office is here in Geneva. I think we're about 85 people at the present time. And we have 4 other very small offices located around the world. And the first one we set up was it's actually not in Boston, it's just outside Boston, which deals with the North American continent. We also have a very small office, just 1 person in Sao Paulo. We have an office of 7 people now in Singapore. And there's also an office we have in Sydney. In fact, in the Sydney office runs one of our conformity assessment schemes. So we do actually have small offices around the world. I guess in total we must be just over 100 people, because there must be about 20 people dealing with all those in all those offices. Okay. And as I say, the sun never sets on the IEC. We always have someone awake somewhere. You saw the first slide, we talked about the need to have manufacturing interests included in the IEC. And today, the industry focus stays very, very, very important. The people who run our technical committees, about 90% of the officers are actually working from industry. So it's the big multinationals, typically, or big trade associations, which are actually running the technical committees. It responds to needs, to industry needs, and is very much market oriented. We'll do what the industry, we'll develop standards that the industry needs. So market relevance is an important aspect of what we do. What is important also is our relationships. We don't live in an isolated world. And we have relationships with a whole pile of organizations, both at the international, the regional level, other organizations, and even with industrial trade associations. So the international level, well, obviously, the one we have to work with most closely is our colleagues in ISO, because they're doing something similar to us. In fact, they work very much the same way, but they're doing on different types of products and services. The other ones you see there are, in fact, all intergovernmental agencies, the ITU, the ILO, the WHO, IMO, OIML, and BIPM are all intergovernmental agencies. ISO and IEC are non-governmental organizations. Okay. Regional organizations, CENELEC is the European Organization for Electrical Standards. And particularly at the European level, there's an importance to have a strong relationship because European standards are largely mandatory within Europe. And particularly CENELEC have taken a commitment to make use of international standards wherever they can. Other organizations such as IEEE, CIE, and CGRE. IEEE is a big scientific organization based in the United States, though it does have memberships everywhere. The CIE deals with illumination, CGRE with power transmission, and then with industrial trade associations as well. So we have agreements with, currently it says there are 156 organizations. Okay, so of one kind or another, we reach agreements with them. So we don't work in a vacuum at all. So how are standards developed? I don't know if they've had anything about that at all or not.
Not yet.
Okay, so you'll get a...
This year you've been...
I'm the first, okay. Right, well, you're going to learn a lot more about that. I've only got about 2 slides on this, I'm afraid, but it'll give you a background of what happens when you develop a standard. There's a process in place. It's a standards development process. The whole notion of process is vital to the concept of standards being accepted. The national committees are our members, and they're the ones who vote on the standards. They don't necessarily develop them, but they're the ones who vote on them once we've written them. For each field of activity, we set up a technical committee. And you saw between the technical committees and subcommittees, we're at about 170 something or other today. There's a 6-stage process for developing a standard. Okay, so again, I said how important the standards process, development process is. The new proposal, so within the technical committee you will have a lot of subjects that need to be dealt with. So the UHV AC will be developing a whole bunch of standards in the future. I don't know how many, it could be 10, 20, 30, 100 or whatever. So they break down their work into projects or proposals. And each of those proposals has to go through these 6 stages. The new work proposal. In the working group, you create a working draft. Once the working group has reached agreement on it, the document goes out for a committee draft. The committee draft goes out to all our members to allow them to comment on it. So that there's an open process allowing people to comment on the documents at the committee draft stage. The next stage we're getting on is what we call the voting stages, because this is when the document starts going out for vote. The CDV stage, we call it in the IEC. Our colleagues in ISO call it something different. And it largely does the same thing. We send the document out for vote, and that's the first time it goes out for a vote of any kind. And the document actually has to be approved by a 2/3 majority of the people voting. From next year, I hope, because this is one of our projects, we will in fact be allowing the public to submit comments on those documents as well. The general public. Okay? On the CDV. By that time, the document is supposed to be relatively mature. Okay? We're not expecting people to, the public to, again, this is something we're a bit concerned about because we're not quite sure how it's going to end up, what it's going to end up doing. There's 2 choices. Either we're going to end up with 10 people who comment on documents per year or something like that, which would be fine, or we end up with millions, and then we probably aren't going to be able to cope with it. And then there's a final formal stage, the FDIS. It's a simple 2 months yes-no vote, up-down vote. And then we publish our standard. Okay? Standards can be for products, services, and processes. We heard that in the definition. Okay? Good standards talk about the how. Talk not about the how, but about the desired result. So you don't talk about design. You talk about what it's supposed to do. Okay? A good standard will specify performance, safety, external characteristics, things such as interoperability. And if you do it properly, there will be many ways of designing a product to respect the requirements of a standard. We don't manage this perfectly, okay? We have got standards which do lay down specifications, particularly when you're talking about plugs and sockets. The thing's got to have some mechanical specifications or else it isn't going to work, okay? But even there, you should be able to design your plug to have the sort of shape, the color, and other aspects around it. Okay? But a good standard does not talk about design. It talks about performance. Performance is the most important aspect of it. And safety is, in fact, a performance characteristic as well. We talked a little bit about the differences between one country and the other, and it's important that the international standards particularly are relevant at a global level. That's not always possible to do because there are what we call essential differences sometimes from one country to the next. The environment is one. It's hot in some countries, it's cold in others, so that's an obvious one. And there are also infrastructure things. I'm talking about a non-electrical one here. Let's take driving on the left and driving on the right. For example, there are countries that drive on the left, countries that drive on the right. You can't swap them over because it would end up being chaotic and it would be outrageously expensive to do that. So you don't do that. And there are same problems in infrastructure, electrical infrastructure. There are things that are simply too expensive to change, like the plugs and sockets. So you just don't do it, you live with it somehow or other and put up with it. So that's what we call global relevance. And our standards try and cope with that. So you'll find standards that say in the 110 volt world, in North America we have 110 volts, you do it this way, and in the 220 volt world, you do it another way. And that's just the way it is. A couple of quotes from the WTO technical barriers to trade. And again, I'm talking about methodology of standards here, because I think it's important that these things come into here. International standards need to be relevant and respond to regulatory and market needs. I think that's important. Regulatory, so that these are things like laws and directives and things like that that come from high up. So you need standards to implement those directives, regulations. And also you've got standards that respond to market needs, but aren't there for regulatory reasons. The vast majority of our standards have got nothing to do with regulations. Probably 90–95% of them. They should not give preference to the characteristics or requirements of specific countries or regions. You remember when I talked about the origins, it was the British trying to impose their requirements on the rest of the world. That's gone, that's finished now. Okay, the world is a much bigger place. So don't give preference to particular countries or regions. And again, this requirement to be performance-based rather than design-based. Okay, so that's an important aspect of standards development. And you'll see that, I think, next week when you hear about MPEG. At least I hope so. So how do the standards, are they used? You have a process in place to adopt them nationally or regionally. In some countries, you have a formal process to have them adopted. Or they can be even adapted or used directly by reference in regulations or laws. So that's how standards get implemented through government. Standards are used in regulation, and these 4 areas of activity are the areas that are most covered by regulation. Electrical safety, health, the environment, and electromagnetic compatibility. Sorry about the last one, but it's a heavily regulated area. Electromagnetic compatibility, hold your mobile phone against another electrical appliance and you'll hear it humming. That's why they tell you to switch them off when you get on aeroplanes, because they do interfere with other systems. Okay? They won't necessarily bring the plane down. They probably won't, but they will interfere. And you don't want that to happen. And there are lots of standards on electromagnetic compatibility, and it's a highly regulated area. Because you don't want appliances interfering with each other at all. I think the other 3 are fairly self-explanatory. Okay? Hope so, at least. So why do we write standards in the first place? Well, I'm going to look at that very briefly from a few perspectives. And the first perspective is you, end users. What use are standards for you? Well, they allow you to compare specific parameters. When you buy an oven, you can compare specific parameters of that oven from one manufacturer against another. And you're not comparing apples and oranges. You're comparing something that's similar from one appliance to the next. So you've got knowledge which allows you a better choice of your activities. You can choose a product or service from alternatives. It's an opportunity to test and compare, and it makes things much easier for you. So for the end user, there are clear benefits from standards. It's not just fictive. Oops, wrong way. What are the benefits of standardization for our society? Well, contrary to what people say, there's a positive effect on innovation. There are some people who, instinctively, you could say that standards would stifle innovation because you're obliging people to produce a product to that standard. Remember what I said, that a good standard allows you to innovate. And on the contrary, it allows you to innovate much more effectively. It has a positive effect on trade, particularly on exports. It promotes intra-industry trade, so it means that industries trade with each other. A good standard with interoperability will allow industry to trade with itself. It encourages technology transfer, and that is something that's very, very important in the developing world. There have been all sorts of studies on the economic benefits of standardization. I've no doubt Daniele will be talking about that later, but it's reckoned that standards contribute about 1% to the GNP of a country. There's a big study in Germany, which is probably the most respectable study, which gave that magic number. And you can see with the increase in standards, increase in world trade as well. I don't want to dwell on this because I think other people will be talking about it. So now let's move to a real standard. IEC publication 1161 and 140, protection against electric shock. It's what we call a basic safety standard, so it doesn't actually apply to any individual product. But it is, and it does form the basis of the safety requirements for all electrical appliances. So it gives general rules of how you protect appliances from electric shock. So it contains fundamental safety requirements applicable to everyone. Really, it's got two chapters. How you provide basic protection. In other words, how do you prevent electric shock occurring in the first place? And there's a whole list here of ways of doing that. Again, I don't want to get too heavily involved in what those ways are. Some of them are fairly obvious if you think about it. Barriers or enclosures. If you can't touch the dangerous part, you're not going to get an electric shock. The barriers or enclosures, that's a very simple way of preventing against electric shock. Placing out of arm's reach. Those of you, if you've got small children, you don't want them touching electrical appliances. Put them high up. Go and look on any household with small kids. You'll find mum putting things high up so they don't get in the way. So there are a whole pile of measures you can take to prevent against electric shock. And a lot of them are not really high-tech at all. They're very, very simple. Okay? But they're all described in this standard here. What happens when things go wrong, when you have a fault? Okay? Fault protection is a very important aspect when you're dealing with electrical safety. So what happens when there is a fault? And again, you've got a list here, and this does get a bit more technical. And again, I'm not going to go into what those things are. The standard also contains provisions about what to do, or about the sorts of things you should be doing to protect when you have a fault in your appliance. So basically, if you read between the lines of what I've just been saying here, all electrical appliances contain protection against electric shock in the first place. They're designed, you have to design your appliance not to get an electric shock in the first place. They also have to be designed so that if there's a fault in your design, there's a secondary protection there as well. So what happens when there's a fault? And again, one of them is fairly simple, automatic disconnection. Okay. There's a way of disconnecting the electrical supply so you don't get an electric shock. And again, some of these are more technical than others. And that's one of the IEC's most important standards. Okay? Very simple, really. If you go back to here, a lot of that is very just simple common sense. It's not high-tech at all. Okay, another example of a recent IEC standard, the universal phone charger. And our friends from Apple, of course, as usual, don't follow the rules. They do everything differently. They're, in fact, the only manufacturer who don't use this charger. Pretty well everyone today, pretty well every single mobile phone that's used today uses the micro USB charger. You can use any charger, basically, to charge a mobile phone. Other than iPhones, of course. And this actually rose from consumers who complained about the fact that we were throwing away chargers every time you bought a new mobile phone. You could ask the question, is it really necessary to buy a new mobile phone every year? But okay, that's the way our society lives today. And the secondary question is, do you actually need a new charger every time you buy a new mobile phone? Well, the answer is no, you don't. And I think we'll be coming over the next few years to the sale of mobile phones without any chargers. You just buy the charger separately if you need it. Okay? So this is an important societal standard in the sense that it will reduce environmental damage one way or another. Okay, how do you get involved in IEC work? Or why do you get involved in IEC work? Well, it depends what your perspective is. Obviously, if you're involved in the work, you can influence the content of the standard. I mean, the guys who sit on the committees are people working for companies, governments, or whatever, and you can influence the content if you're going in there. You learn about what's about to come along, so you can make changes to your production if necessary. Product safety and quality. We've heard about the importance of safety. And again, international standards, and we'll see a video about this, allow you to rationalize your production because you're producing a single product, hopefully valid in global markets. International standards are vital for governments because they're a good source of ways of implementing their laws and regulations. So they're a recognized source for compliance to the World Trade Organization's technical barriers to trade agreements. And they provide detailed interpretation of the law. They allow you to demonstrate that you're complying to the requirements of the law or of your regulation or directive. Multinationals are some of the biggest participants in the standards process, and they do it to get acceptance in global markets, obviously to influence the content of the standards, develop anticipatory intelligence, networking, talked about coffee breaks, and they remain vital, save time and money. You want to end up with a single product which is usable throughout the world, and again the safety and quality aspects come along. So, important aspect, you get involved through IEC national committees. That's the only way to get involved. As I said, next year we may be allowing the general public to comment on some of our documents, but again, it'll be an experiment and it won't be on everything. Let me quit standards and finish off by talking about conformity assessment. So this is what the evaluation of a standard, whether a product meets the needs of a standard. The IEC's conformity assessment systems are global, so they look at trying to apply the standards at a global level. They're multilateral. What I mean by that is that you have agreements between the participants in the various countries amongst each other. They're not bilateral. So they make a star network amongst each other. They're all based on international standards. And currently the IEC operates 3 conformity assessment systems. The IEC EE, which deals with electrical safety of electrical appliances. So you want recognition that the safety requirements are being, you want global recognition that the safety requirements are being met of your product. The IEC EX, that deals with appliances that are used in explosive atmospheres. Now, explosive atmospheres are a highly regulated area. Just as an example of explosive atmosphere areas, you've got oil platforms, not surprisingly. You have grain silos. Grain dust particularly is highly explosive. You have lots of electrical installations in grain silos, and they are subject to some of the tightest regulations that exist in the world. So you want your equipment to be tested and that test to be accepted to be used in grain silos or whatever. And the oldest of the conformity assessment systems, the IEC systems, which deals with the production of electronic components. And that's dealing much more with the process by which electronic components are being manufactured. You've got three types of conformity assessment: first party, second party, and third party. Let me just explain to you what that means. First party conformity assessment is when the manufacturer, so it's a self-declaration by the manufacturer that their product is in compliance with a standard. Let me repeat that. The manufacturer says, my product is in compliance with a standard. Can you tell me what the flaw in that is? Okay, I'm going to give you an example of a first-party declaration, the CE mark. Okay, the CE mark you'll find on pretty well everything you buy today, whether it's electrical or non-electrical. The CE mark is a requirement within Europe, so it's only valid within Europe, even if you see it elsewhere. It has outside Europe, it has no validity whatsoever. It's a declaration by the manufacturer of a product or the importer of a product for a product that comes from outside Europe, that the product meets the essential requirements of the relevant European directives. How many of you thought that CE mark was something about the quality of the product? Nothing whatsoever to do with the quality of the product. In other words, if we're talking about the CE mark of an electrical product, it's a declaration by the manufacturer that it meets the requirements of what are called the low voltage directive. That's all. So it's just a declaration by the manufacturer. May be valid, may not be valid. Toss a coin. Okay? Absolutely right. Second party is when you do the test yourself. Probably going to have a bit more confidence in what's going on. All right? So the person who's acquiring the product actually does the conformity assessment. And third party, well, you get someone outside the system to do it for you. And that's the most unbiased way of doing it. And the IEC's three conformity assessment systems are all based on third-party evaluation of the products. They're based on peer assessment. In other words, people from different laboratories evaluate each other, and then mutual recognition of the test certificate of one laboratory by another. So it's peers evaluating each other. Let's see what happens. It's a standard on ice makers. Find out what it was about, this one. So this standard is a standard on the safety requirements of ice makers and ice cream makers. So the manufacturer makes the appliance and has it tested, usually locally, but it doesn't have to be, for conformity with the IEC standard. The certification body then issues a certificate. But that certificate would normally be valid only in the country where the test has been carried out. The way it works with the IEC's conformity assessment system is if the manufacturer now decides he wants to sell the product in another country, he sends the certificate to a certification body in that second country. Doesn't send a fridge, he sends a piece of paper. That piece of paper is recognized because they've gone through this mutual recognition process, and the second certification body issues a second certificate without having to retest the fridge. Having received the certification, the manufacturer can then export the product to that second country. It may sound an awful lot of paperwork, but it comes to costs an awful lot less than actually having to send a fridge there and have it tested. Depending on what kind of conformity assessment you're doing, You may even need to have your manufacturing process examined. And that becomes really very, very complicated. So you are making here huge savings in terms of manufacturing. And that's a vital interest for global trade. In an ideal world, and we're a long way from an ideal world, you would have one test, one certification, and a single mark on the product. Have a look on any plugs and sockets and you'll find thousands of test marks on them. So the IEC conformity assessment systems, and again, this is a very brief overview you've had there, builds confidence, particularly reduces costs. It accelerates market access, so you get your product much faster to your secondary markets. It allows you to expand the markets, because you may be going into markets you wouldn't have dreamed of going in, because they would have been too expensive to go into. And again, they will support global trade. I'm going to finish off by showing you a final video. It's by the CEO of Robert Bosch. And
Bosch was a global company before anybody used the word globalization already. We are more than 100 years already in the United States. We were last year 100 years in China, and we are next year 100 years in Japan. We had about 90% sales outside of Germany already in the beginning of the last century. Internationalization is really in our DNA. In all our activities, we never strive to have a short-term profit maximization. We always see the need for long-term orientation. We know also clearly that sometimes, for example, in a new development of a new system or a new product, it takes time. I would say the business thinking and the social thinking, this balance goes even back to our founder, Robert Bosch. What we have added is the environmental issue. You have to combine this balance, business, social and environmental, also with the principle of sustainability. And this is something Bosch has done for many, many decades already. To have really the sustainability to bring something successful to the market. If you are an international company, as we are, and active in all markets around the world, I think then you realize how important it is to have standardization in the markets. You have to imagine what kind of double work you have to do, what kind of additional work and efforts you have to spend to have different standards in the different markets. We are convinced that if we don't have standardization in the different markets, we waste a lot of efforts and a lot of money. So we have to come, first of all, for our own benefit, but I see it also for the benefit of our customers, because they can then be sure that we have to fulfill these international agreed upon standards, and they can be sure that they have a real tangible benefit out of it. There are regional and smaller organizations who try to organize something. I think this is totally the wrong way. We should really come to the overall global international standardization organizations, which they really give the standards and the requirements for all the markets around the world.
Two messages from that. Internationalization, international standards are important. They're the ones that matter to a multinational. Well, that's not totally surprising, I suppose. And the other one, I think, perhaps more important to you, is this issue of long-term. The standards don't happen overnight. And that's reflected a bit, I think, also in Mr. Reichel's video, which we saw earlier on. He's in it for the long term. He's not in it just to come here and go again. Standards take a long time, and it's a long-term investment. You won't get short-term benefits, whether they're monetary or otherwise, out of getting involved in standards. You see that as a long-term thing. So I think that message came over fairly clearly in that interview as well. Okay? And I think that is it. Thanks very much. Have you got any other questions?